Alright, here's a quick review of solving, factoring a sum and difference of cubes. So if we look at a sum of cubes, we're looking at something that would be written in the form of a cubed plus b cubed, which factors to a plus b, a squared minus a times b plus b squared. The way we always remember for any cubes, sum or difference, is SOAP. The signs are same, opposite, always positive. So when we're talking about same, we're talking about this in relation to this, so it's the same. This one is always opposite of the one you start with. And then this last one is always positive. So using that same thinking, let's look at a cubed minus b cubed. And so when we do that, the signs are same, opposite, always positive, and we actually have the same exact factoring as above. So a minus b, a squared, a times b, and then b squared. Nothing changes. So let's look at a quick example. If I have 8x cubed plus 125. The first thing I always want to do is make sure there's no GCF between this term and this term. If there is, I want to take that out, make it simpler right away. In this case, there is no GCF. So I go right to recognizing the fact that it is a sum of two cubes. What would be the cube root of 8x cubed? That would be 2x. It's the same sign. And the cube root of 125 is 5. Now I can use both of these to figure out the next couple. So it says I need to find, let's do the signs first. So I have plus, minus, plus, because same, opposite, always positive. So if this is a and then it becomes a squared, I got to square 2x. I got to put it here, so it becomes 4x squared. This is a times b in the middle here, so a times b would be 10x. And then lastly, I would have 25. As I look at it, I just want to double check, did I completely factor? Between 2x plus 5, there is nothing more I can take out. And between 4x squared minus 10x plus 25, there's also no common terms I can take out. There's no difference of squares that appear, no more sum of cubes. Again, I'm going through all of my factoring methods to make sure I have in fact factored it completely. And in this case, I have. Alright, so let's look at a same, opposite, always positive difference of cubes. This one is taken right from the midterm review packet. Some of you may have had trouble, and I have had a few questions on this one, so let's take a look. First off, what I always like to do is I look for a GCF. When I look for a GCF here, I would have 27, and when I take 216 and divide it by 27, I'm left with 8. So I get 8x cubed minus 1. And I think this one just screams out, all right, I'm a difference of two cubes. However, say you did not look for a GCF here and you went about solving it in a different manner. What I would do is, let's go right to here. All right, so we recognize that 216 is a perfect cube. It's 6 x cubed and then 27. So what I would have is, for my same, opposite, always positive, and then I would go 6x, I would go 3, and then when I go to here, I got to square it, so I get 36x squared. Multiply them together, I get 18x, and then lastly I get 9. So taking a look at this, I have factored it correctly for a difference of two cubes. However, I got to look for a GCF. In the first one here, I can take out a 3. And when I do that, I'm left with 2x minus 1. In the second one, if I look at it, it looks like I can also take out a 9. When I take out a 9, I'm going to write it out front. When I take out 9, I'm left with 4x squared plus 2x plus 1. And my final answer then would be 27, 2x minus 1 4x squared plus 2x plus 1. And if you take a look at the midterm review answers posted on the Edmodo class page, you will notice that this is exactly what you should have. So if you forgot the GCF in the beginning, luckily 216 was a perfect cube, but if you forgot that in the beginning, you could still find it in the end and still have this fully factored. That would be an acceptable answer. Mad Math, Mathletes United. Just for you, period 3.